Last section. Hopefully you've learned all these words before. Coordinate plane, x-axis, y-axis, origin, quadrants, ordered pair coordinates. Hopefully you have. If you haven't, here's how to learn all these words. Just pay attention, copy down the notes. For those of you who have, this will be a great review. We're going to be dealing with this stuff all year long, so you need to know. What is the coordinate plane? The graph, the whole grid. Just this, right? Coordinate plane stops right there, doesn't it? It goes on forever. This is just a small portion of the coordinate plane. The coordinate plane extends, that's what this arrow here means. Forever up, forever left, forever right, forever down. This is an infinitely huge coordinate plane. We only show this much because there's no way we could show the entire thing. It's not possible. We show what's interesting, the stuff around this part right here, most of the time. So the whole grid and everything else beyond it is the coordinate plane. What is the x-axis? The horizontal one. Good. This axis right here is the x-axis. That's the horizontal axis. What word looks like horizontal? The horizon. You guys know what the horizon is, right? That's like where the sky meets the ground. If the ground is flat, then you would see the ground here and the sky here. That's the horizon. Horizon's flat. The horizontal axis is the x-axis. The y-axis then would be the vertical axis. Good. So this is the y-axis, and we're going to call that the vertical axis. All right, what's the origin? Doesn't have to be. Where what intersects? Good. Where the x and y axis intersect. It's where the x and y axes, the plural of axis is axes, where the x and y axes intersect, not axes. So on the graph, that would be right here, where they intersect. So I'm going to put a dot there, and I'll call that origin. What are quadrants? The little square, so this is a quadrant right here. There you go. They're formed by the x and y axes. We usually call them out by Roman numerals. 1, 2, 3, and 4. This one would be quadrant what? It's 1. That's a Roman numeral 1. Quadrant 2 is where? To the left. Quadrant 3, below quadrant 2. And quadrant 4, Roman numerals. 1, 2, 3, 4. What is an ordered pair? We don't know? Go ahead. Yeah? Yes, that's what it looks like. An ordered pair looks like parentheses with two numbers, and then they're separated by a comma. That's what an ordered pair looks like. If I put a point on here, I could represent that point with an ordered pair. You're right, those are coordinates. What are the coordinates of that ordered pair? This is like a number line, right? What number would be right here on the x-axis? 0. So if I'm going this direction, what numbers am I looking at? These are the negative numbers. This is the x-axis, but this is the positive side of the x-axis. This is the negative side of the x-axis. This is the positive side of the y-axis. This is the negative side of the y-axis. So we have the x-coordinate is negative 6, isn't it? Comma. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Comma. Positive 1, 2, 3, 4. So the ordered pair there would be negative 6, comma 4. That's an ordered pair. How did we get the ordered pair? We came up with the coordinates. So the coordinates are x-coordinates and y-coordinate. The x-coordinate in an ordered pair goes where? The left, the first one. The y-coordinate goes to the second one. Anybody know why it goes x, comma, y? Yeah. Yeah, it's alphabetical order. If you had two different numbers like A and B or M and N or L and Q, usually you would list those in alphabetical order. So that's why it's x, comma, y. Okay, x-coordinate, x comes first in the alphabet, so x-coordinate comes first in the ordered pair, generally. What's a solution to an equation? The answer? That's it? A solution to an equation. Is the answer. If you have an equation with one variable in it, then you're just going to wind up with like x equals 2 or something like that. That's what we've been doing in the last few sections. But the solution to an equation that has two variables in it, which is what we're dealing with, solution to an equation with two variables is going to look like an ordered pair, which will be x, comma, y in that order. So if you find a number for x and a different number for y maybe that makes an equation true, then your answer will look like this. You'll write your ordered pair down and then you'll put a box around it showing me that that's your answer. So for example, is 3 comma 10 a solution to the equation y equals 4x? I have no idea. What should I do? Plug in the numbers. And our word for plug in the numbers is substitute. Good. So I need to plug in a number for y, and I need to plug in a number for x. What am I going to plug in for y? Why 10? And the second number in an ordered pair is the y. This is my x, this is my y. Okay? That's always going to be the case. If you need to label the x and the y, we're going to be doing that a lot this year, labeling above the x and the y. Go for it. So now I know that y is going to be 10, so like you guys said, I'll substitute in 10 equals, and what am I going to write now? 4. How do I write 4 times 3? With a parentheses. Why do we use parentheses? Because we're substituting. Good. Okay, so on the left, what do I get? On the left, I get 10. There's nothing to do, so I just keep the 10. And now I have equals, and I'm not sure if it equals or not. So maybe I should put a question mark above that equal sign above it. 4 times 3 is 12. Is that true? No. So what's the symbol for not true? Good. And I should probably answer the question now. The answer is no, because the question says, is this a solution? So the answer is no. Okay? This is showing your work. If it said explain, this would be your explanation right here. That's showing your work. And then the answer, though, that we're looking for is no. Okay? You guys think you could do these 4? All right, each one of them is using this exact same equation. So all 4 of them will be 4 different problems using this guy right here. Go for it. So for the first one, what will I write when I do my substitution? So I'm substituting both coordinates in. This is my x and this is my y, so I'm going to write 20 equals 4 parentheses 5. So when I simplify that, on the left I get 20, on the right I get 20. Is that a true statement? Yes. Oops. That's what I want, right? Equals. So the answer here is yes. Second one, -5 and -20. What do I do? So I'm going to write good. Remember to watch your negative signs. If I had $1 for every time I said that, I could probably retire by the time I was 40. What's next? Is that true? Yes. So the answer here is yes. Next one, what do we do? Four parentheses, -20. Again, make sure you are entering these things in correctly. This is your x-coordinate, this is your y-coordinate. The y-coordinate goes in for y, the x-coordinate goes in for x. So we get -5 equals what? -80. Is that true? Nope. So I do that, and then I say no. Last one. What do we do? Freak out because there's a decimal. 6 equals 1.5. So 6 equals, it is 6. Did you need to reach for a calculator for that one? You don't have to. Do you know what 15 times 4 is? Think like a clock. There's 4 quarters in an hour. Each quarter is worth how many minutes? 15. So 4 times 15 is 60 minutes, right? 1 hour. 4 times 1.5 then is 6.0, or just 6. So is this one true? Yes. That's the idea on these problems. In this class, throughout the year, we're going to be using tables and equations and graphs on problems all the time. So we're kind of getting started with that. The same relationship can be represented all 3 of these ways most of the time. So we have a story here. Carrie and her sister Kim were both born on October 25th, but they're not twins. Kim was born 2 years before Carrie was. So, who's older, Kim or Carrie? Kim was born 2 years before, so Kim is older, right? So if I set up a table and I call it years, Kim and Carrie, year 0, how old is Kim? 2. Who's older, Kim or Carrie? So in year 0, I want to say when Carrie was born, how old was Kim? 2. How old was Carrie? 0. In year 1, how old was Kim? How old was Kim? In year 1, 3. How old was Carrie? 1. In year 2, how old was Kim? How old was Carrie? Okay, do you see how that's working? Okay. Kim's always going to be older than Carrie by how much? 2 years, no matter what. So that is how you could represent this using a table. How many years have gone by? How old is Kim? How old is Carrie? We need an equation for this. I need an equation, yeah.
So y equals...
Who are you calling y? What are you calling y? I want 2 variables. We actually don't even need this column right here. I have two variables, Kim's age and Carrie's age, right? Okay, that would work, that could work. Let's use x and y. Using your equation that you came up with, you'd be calling Kim y, and you'd be calling Carrie x. So now that we know those two variables, can we write the equation now? Not yet. That's the next chapter. Y equals what? Yeah, basically, right. 2 plus x, x plus 2, same thing. It's exactly what you said, k equals c plus 2. I just used different variables. It's the exact same equation. In this case, I preferred to use y and x because this is the first time we're writing an equation, and usually we're going to be using y and x when we're solving equations. In story problems, though, k and c, perfectly acceptable. So now we have to graph this. How should I graph this? Notice I gave you a grid that has no what on them? The origin's not there. There's no axes on there. So it's up to us to define everything and come up with a scale that makes sense. We're going to do this all year long. Where should I put my axes? Directly in the middle, right there? Yeah, that's what I did. Is that where I should put my axes? Some people are shaking their head, no, why not? Yeah, there's not going to be any negative numbers. If I put my origin right here, I'm going to have negative x ages. I'm going to have negative y ages, and none of this down here is going to be useful to me. So there's no point in putting quadrants 2, 3, and 4 on there. Just quadrant 1. How do I do that? Yeah. My y-axis will be over here, and my x-axis will be on the bottom. Basically what I've done here is I've sort of zoomed in on the first quadrant. Quadrant 2 would be over here, quadrant 3 would be here, quadrant 4 would be here. But all I care about is quadrant 1, okay? Now, we have Kim and Carrie, and we know what variables those names correspond to. So I need to label my axis here. Who is on that axis? What axis is that? That's the x-axis. My x variable goes with Carrie, so I'm putting Carrie. Carrie, what about Carrie? Carrie's shoe size. Carrie's age. And then what goes on the other axis? Kim's age. And that would be which axis again? Good. All right, so now we have Kim's age. Now we've got to come up with a scale. Should we go by hundreds? 1, 2, 3, 4? 2, 4, 6, 8? Do we need to go by twos? In this case, we can go by ones. When Kim's one, or when Carrie's 1, when Carrie's 2, when Carrie's 3, we have 14 lines going on here. So that's plenty of space. I can go by 1, so I'm just going to put 1, 2, maybe 3, 4, 5. You don't have to label every single line. 3, 4, I'll put 5 here, and then 6, 7, 8, 9, 10 here, and then 14 all the way over here. Scale for Kim's age. Same thing. This will work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Notice that I did not write every single number in there. You don't have to. Just make it clear what you're doing. Okay, now we want to make some ordered pairs. We have Kim and Carrie. We need to make these dots happen on here. So, how do I graph the first one that I have? I have 0 for Carrie's age, 2 for Kim's age, so I'm going to put a dot right there. I have what next? 1, 3, so I'm going to put a dot there. And after that? 2, 4, and put a dot there. What kind of a graph does that look like it's going to be? Yeah, kind of like a line, right? It's not actually going to be a line. We'll talk about that later. But it is dots that are kind of forming the shape of a line. And that shape of the line would follow this equation right here. Pretty soon we're going to know how to graph just from an equation. But that's how you do this problem. A table, an equation, and a graph. That's what it's asking for. Okay, we have a figure here at the top of the page. For you guys, your figure is in black and white. So it looks gray instead of blue, and the stars are black instead of red, but that's okay. The table shows the relationship between the number of star tiles, x, and the total number of tiles shown in each figure. In this figure, how many tiles are there? We got the 2 black ones, we got the star one, we got these 4 blue ones, and it's hard to tell, but there's 2 white ones in there also. So there's 9 total tiles. So the table shows the relationship between the number of star tiles, x, and the total number of tiles, y, shown in each figure. Okay? How many tiles would there be if the figure had 8 star tiles? Okay, so let's take a look at this guy. How many star tiles do we have in figure 1? How many star tiles are in figure 2? And in figure 3? Okay, so that's where they're getting this information from. Star tiles, 1, 2, 3. How many tiles total are there in figure 1? 9. So notice they have a 9 right here. How many total tiles are there in figure 2? 18, and in figure 3? 27. So that's where these numbers are coming from, okay? Now they don't show you figure 4, but from the pattern that you can see here, can you see how there's 4 star tiles and therefore 36 total tiles? What's happening each time to go from here to here? I'm not adding 8 here though. Multiplying by 9, yeah. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9. Okay, so to answer the question, how many tiles would there be if the figure had 8 star tiles? 8 here, then times 9 would be 72. So 72 is the answer to that question. The power of observing what's going on in a figure and making a table is what this problem is trying to show you guys. It's very easy to come up with an answer once you analyze the figure and come up with a table. All right, let's do this first bullet here. Make a table showing the number of black tiles and the total number of tiles. And then it asks how many tiles in all would there be in a figure with 24 black tiles. So let's make that table. Just like this first table here. I'm going to go over here since I have a little bit of room. So we're looking for what tiles? Black. And let's call that X. And then what else are we looking for? The total number of tiles. So we'll call that total. And we'll make that Y. So here's my table. Figure 1. How many black tiles do we have? 2. How many total tiles do we have? 9. Figure 2, how many black tiles do we have? 4. How many total tiles do we have? 18. Figure 3, how many black tiles do we have? 6. And total tiles? 27. All right. We want to know how many tiles in all would there be in a figure with 24 black tiles. Well, what's happening each time here? So there is a way to generate an equation for this, but we're not going to do that here. We're just going to try to make some logic happen so that we can come up with an answer. In a figure with 24 black tiles, let me ask you this a different way. What figure number would we be on if we had 24 black tiles? How'd you get 12? So yeah, this is figure 1, this is figure 2, this is figure 3. To get the figure number, what she did was divide the total number of black tiles by 2. Okay? So we would be on figure 12, which would give me 24 black tiles. Well, what's the relationship between the figure number and the number of tiles total? What's that? Multiply by 9. So if I take 12 and I multiply by 9, I get 108. So the answer is 108 tiles. Again, the power of the table lets you go back to what we just did over here and then come up with the actual answer. Last one, make a table showing the number of gray tiles and the number of white tiles. How many white tiles would there be in the figure with 24 gray tiles? So for the second bullet, make a table showing the number of gray tiles and the number of white tiles. So that tells me what I need to do. I have gray, and I'll call that one X, and I have white, and I'll call that one Y. I don't know if that's how you set it up, but that's how I'm setting it up. So in figure 1, how many gray tiles do I have? For me it looks blue, but how many gray tiles do I have? There's 4. How many white tiles are there? 2. For figure 2, how many gray tiles do I have now? There are 8. How many white tiles do I have? 4. For figure 3, how many gray tiles? 12. And how many white tiles? 6. 1, 2, 3, 4, 5, 6. Do you see the pattern that's going on here? What's the relationship between the number of gray tiles and the number of white tiles? It divides by 2. However many gray tiles I have, I'm going to have half as many white tiles. You guys all see that? Okay. So now let's go back to the problem. How many white tiles would there be in a figure with 24 gray tiles? Well, I have 24 gray tiles, and we said that the relationship here is divide by 2. So 24 divided by 2 would be, so the answer is actually 12 white tiles. That's the whole section.